and C+1 and make it entirely 0. M square into another looping variable which is near about m cube. And right on the code over here you'll say dp of ij equal to whatever mini you make, and right over here you insert a line if this state has been previously visited. That's it. So if you just write these couple of lines, I think you should be able to solve this. So what I'll do is I'll just keep a vector int dp of definitely C+1 cuts vector int C+1 of -1. Amazing. Now you can just take this dp and just copy paste this, and you can say and of dp, and over here you can say dp of ij equal to this, and right over here you can say dp of ij is not equal to -1. You can return dp of ij. Amazing. So over here just make sure you pass dp, over here pass dp, and now you can just run this. And so if you run this, this should be running fine. Yeah, this is, and if I submit this, you'll see this is giving you an accepted answer. I hope it does. It does. So what is the time complexity? Two changing variables of C+1 and C+1, C square and a for loop C cube. Yeah. Two changing parameters will yield to n square number of states. Now two changing, like if I discuss the time complexity, we just quickly write the time complexity. Two changing parameters I and j will give you n square or cut square, m square into another looping variable which is near about m cube. Space complexity, we go of m square for the array and auxiliary stack space. And I'm not interested in the stack space. So how do you optimize this? Tabulation. Tabulation is the way to optimize this. Yes, tabulation is the way. And how have I taught you tabulation? Copy the base case. Step 1. Copy the base case. Write down the changing parameters. In opposite, copy the recurrence. So if I go and copy the base case, do I have a base case? I do have. What is the base case? Let's go back. It's I greater than 0. It's I greater than 0. It's 0 only. So instead of doing anything, what you can do is, you can just declare a dp of C+1 and C+1 and make it entirely 0. Two changing variables. Where is I being called? Just go and look. You're calling it from 1, comma n. This is your I, this is your j. You're calling I from 1. This happens to go like this. So I will go from 1 to n in recursion. I will go from 1 to n in recursion. So in tabulation, it will be opposite, because tabulation is bottom up. You take those bottom answers and you compute it. So n to 1. What will be j? J is going from n. Shrink, j is n to 1. So I'll take it from opposite. Just you have to write it in opposite. Make sure tabulation is writing in opposite. So take it from 1 to n and then copy the recurrence is the last thing that you will do. So if you have followed the DP series entirely, you know this pattern. I've taught you how to make tabulation easy. So if you know this pattern, it's going to be a cakewalk stuff. Don't worry about that. So what I'll do is now I'll get back here. I'll get back to the code and we'll keep everything the same. Just we'll make this as 0. Yeah, the DP will be 0. And let's write the same thing. So no base case. So the changing parameters will be written in opposite. So please make sure you write it in opposite, which is this. And then you write int j in opposite again, j lesser than equal to n and j plus plus. Perfect. You know the base case is this, which will be 0 always. So you can say this, we don't need to perform because already everything is assigned to 0. Copy every stuff over here. Copy the recurrence. I'll just copy paste the recurrence. See how easy it is. Let's copy paste the recurrence. I remove the return. Over here, dp of index plus 1, j. So yeah, that's what the first thing I'll do. Over here, dp of I of index minus 1. dp of I of index minus 1 is what I'll do. Okay, perfect. So what I've done is I've taken the left and the right. And I've taken this, and this will be dp of 1c. dp of 1c. Now something very important to understand. Over here, if j is at a moment taking index minus 1, and if I is n, it's still taking I plus 1, index plus 1. Okay, so n plus 1 might go n plus 1 as index, so this will be c plus 2. Just make sure for safety, take it c plus 2, because index plus 1, when I is n, will tend to give you runtime error. So if you've done this, try running this, and you will see that this is indeed giving you the correct answer. Oh, it did not. Why it did not? Let's quickly check why it is giving you runtime error. Because I've taken the cuts. Okay, by the way, it will not be n, my bad. It will be from c, and it will be from c, because n is basically the size of the cuts array. So it will be very important that you take it till c. Okay, cool. Now it should be fine. Yeah, it is fine now. And if you submit this, it will give you the correct answer. Time complexity definitely n cube. Space complexity is definitely n square, where n is basically the cut size array, and there's no auxiliary stack space. So guys, I hope I was able to explain you this hard problem. So thank you guys for watching this video. video till the end. So just in case you have liked this video, please make sure you give a like to this. And if you're new to the channel, please do consider subscribing to us. And yeah, it is the season of appraisal. So what are you waiting for? Download the Hirect app from the link in the description.
So alright guys, let me try to explain if I can little bit, right? So let's say we have some area of cuts given, right? So cuts area is given to us, which you can cut to 3, you can cut at 5, you can cut at 7 and 8 and 9 and like this and 12 there. Okay. So first of all, to optimally do the cuts, we have to sort this partition, because when we have some let's say we are making cut at 3 and we have 0 to 3 length here and 3 to 12 length here. So the 1 is here, right, and 12 is here. So these cuts are very in separate things, and we cannot if we go further from here, let's say 7, or let's say here it's 2, right? So if we go here like this, and 1 is here, 7 is here, so we are very let's say 12 is here, right, and 1 is here. So what is the problem here is we are not trying to do this like, okay, because we are doing this, right, and we are doing this, 12 is here, and alright, so this and let's say so like it this is because it's not independent, right? This 1 okay, 1 is here and 12 is here. So this when I choose to cut at 12, then 1, right? If I want to skip 12 and 1, so these 1 and 12 is not independent, they are both dependent, right? But they are in both separate sections. We cannot connect them, right? We cannot call the function. So that's why we need to sort this. Okay. So okay, right? So let's say it is 4, 6, 7, 9, 12, like this. Okay. So guys, we should have what is the length of this array. Okay. The length of this array is 1, 2, 3, 4, 5, 6, 7. Right? 7 is the length of this array. What is the length of length of stick? Length of stick is 12, right? Okay. One more thing, to find the cost, let's say we have this pointer I here and a pointer j here, right? Now in the cuts area, this is cuts area, right? If I doing a cut at 6 and I want to cost, what is the cost of this cut? So cost of this cut would be cuts area of j plus 1 and Alright, J will be here, right? Okay, J will be here, not here. And minus cuts of I minus 1, right? So I will be here. So we will have to insert 0 here, right, first, because yeah. So from starting to 0, right? So I is here, so I cuts 0 and n is here. Alright. So j plus 1 here, right? And now we are cuts of j plus 1 is 12, right? So 12 minus this I minus 1 is 0. The length of this is 12 stick. So cut it will be cost 12. Now what we can do guys is, let's say we can partition here, we can partition here, we can partition here, we can partition here, anywhere in the from I to j, right? Let's say we choose here. Now this area is broken into 0, 1, 2, 3, 4. No, this is there is no 2, right? 4, right? This and 7, 9, 12. Right. Now where is the j and I? All of them. J is I is here and j is also here. In this I is here, j is here. Right. Let's say now I want to cut at this. Okay. Alright. So what is the cut at j plus 1 is 4 minus I minus 1 0 is equal to 4, because the length of this area is 4, right? And one more thing is then again I want to cut it here. J plus 1 is 12 minus I minus 1 is 7, which is equal to 5. Is this length 5 here? No, this is 3, right? Why is this problem? Alright. Okay. No, so here yeah, because the length is still, because stick is at 6, like 6 to 12, right? Cut now 6 to this is 5 length, right? Yeah, so I am right here. I am right, guys. I am right also here also, because 0, 1, 2, 3, 4. This is 4 length. So I am right, guys. Right. So this is how I can fix this. So let's try to code this first, right? And yeah, then we will get that. Okay. So here let code is here. Let's try to code this. Alright. What happened? What? You cannot connect. What happened to my parenthetics? Okay, whatever it is, so let's alright, So let's try to code this first, guys, with recursion first, then we can go forward. Okay, right. Right. So there is no need to check this here. Alright. Now I have this n, right? What is n? N is the stack length, right? So this is vector, right? So I need to, because j plus 1 is there, so what I need to do is first I need to insert something, cursor push back to length of the string, right, at the end, and after that I need to insert some 0 at begin, right? So cuts dot begin 0 I need to insert here. Okay, after that now I need to sort this also, sort dot begin right, and now after that I will give to function of f I will give this cuts to what is I is I think 1, right, and n is the length. Should I give the length or what? Okay, so C, right? Alright, so j is what? J is cuts dot size, right? Cuts dot size minus 1, I think, yeah. And is there anything I need to give? I don't think so. Alright, so this is a function and f, this will give take int and cuts, and we have what? We have this int of I, comma int of j, right? If I is less than j only, in that case we are going to this right, we are entering in here. Alright, so guys, what we can do, alright, so if I is greater than j, we have to return 0 here, in that case, because there is no cost, that so we have this int minimum cost, right, which is, let's say, int max, and we can cut from I to j anywhere, right? So for int k is equal to I, k is less than equal to j, alright, and k plus plus we can cut from anywhere, right? And what is the cost? Int cost is equal to cuts of k minus wait, yeah, cuts of I minus 1, so wait a minute, j plus 1 minus cuts of I minus 1, right, plus f of I, because I have to take the cost from here, cuts, comma, what is the I then? If I am doing I, let's say, if I am doing cut at 3, right, I was where? I was 1, j was at 5, right, so I am going to 3, okay, so I will be what? I think left side will be the same, right, I, or j will be what? j will be k minus 1, I think, yeah. Alright, plus f of cuts comma k plus 1 comma j here, that, and after this many equal to min of many comma cost, I think, right? And after that we have to return many here, right? Okay, return, I think we are doing good here, right? Alright, cursor dot pushback is vector pushback here, something like to the end, because this is a length here. Okay, alright, what is the runtime error? I think we are accessing something which is I minus 1 plus 1. Okay. First j, alright, k plus 1 j here. Let me check this with the guru of ours. Do you know who is the guru? Let me introduce to the guru. Oh, here is the guru, guys. Give me this recursive solution correctly. That means so welcome back to the world of partition dynamic programming. You have brilliantly recognized the cut casting is mathematically identical to matrix change multiplication and the reverse instead of building a function multiplication into a giant machine. You are taking a giant string and slashing it down, alright. Your cost formula and your key loop are mathematically perfect. However, you have fallen to end of the word cut tab and cloning the universe trap, alright. Here is the real world and mathematically breaking down of your code slightly misfire. Exactly how to fix it, create perfect. Bug 1 is end of the world cut trap. Index once, okay. Look at the starting call, return f cuts I1 like that. You gave the lumberjack a stick from 0 to n inside of cuts. Alright, array index 0 holds the number 0 left of the string and the very last index holds the number n. By asking the lumberjack to process the cut from numerical order into trick is just saw and physically cut. Actually right tip of your n, but n isn't cut you where if you ask me, it's the boundary. Alright, so actual cuts you make is 0 between boundary 0, cut 1, cut 2 and all that. Set at all that, so it should do cut set at index 1 through cut all that and cloning the universe term, alright. Cuts I comma j like that, alright. Oh, so every time you make a cut, instead of ending, remember the original blueprint to look at you, to run the photocopier, print a brand new multi-page blueprint. Name the copy. Since this recursion branch sequence you print millions of copies, the C++ cycling cuts without influence. Alright. Real world mathematics 0 to n. Why do we need 0 to n? Why do we sort? Okay, to calculate the cuts of a cut, we need to know the length of the current string. If we evaluate the range with cuts I to j, we are physical boundary string or like all of them as like C. Alright guys, I think I missed a very small things here, right? Alright, so this will be 2 here, and what one more thing, I need to take it as reference. Let's do this. Alright, it's passing. Now this will give us TLE. Okay. Let's see why it's giving TLE, and we can. So TLE is given. Let's convert it to DP. What are the changing variables? We have I and j. So let's create a DP of n vector of int DP, right? And after that, okay, right. So what we take here? What will be size, right? So size here is, I think, n is the length, right? And we are taking this because n was the length step, and we inserted 2 elements. Cuts array. Alright, so wait. If what will be the, so I and j can go from where to where, right? This is the question. So value of I is from cuts array size, right? 1 to cuts array size. So 1 to cuts array size minus 2, which is length of value of I and j. Don't make like, okay, what is I and what is j, right? What is the value of I and j? Alright. Okay, so value of I and j, this cuts size minus 1 to cut size minus 2. So what is the cut size? Let me take this, right? Int m is cuts dot size, right? Whatever it is. Then we can initialize it. M comma vector of int m comma minus 1, right? And this is simple. After it is simple. We pass this DP from here and take it as a reference, right? Like this. Take it as reference and max and check what if it is given. If dp of I comma j is not equal to -1, return dp of I comma j, right? And here also dp of I comma j is equal to this, and we pass dp here also, right, in this functions like this. Let's check what is the answer. Okay, something happened. We have to take this like okay, and it is something. Alright. Oh, it's working, guys. I think it should not give officially now. Alright. Beats. How many? I didn't beat any. What? So for beat, okay, beats 27% only, right? It's so it is fine. And we can also make it to tabulation. For make it to tabulation, guys, what we can do, let's say we will take a dp also, vector of integer, right, dp of m plus 1 in this case, vector of int m. How to initialize that? 0. What is the base case? If I is greater than j, return 0, right? So we initialize this base case as 0. Okay, and alright, so I is going from what? I is going from 0 to n, and j is going from n to 0 or 1, we can say. So what we can do? We go for 4, and I is equal to what? Cuts cn, right, guys? So cuts size minus 2 comma, right, I is equal to 1, I minus minus send for n to j is equal to 1, j is equal to cuts dot size, right, minus 2 j plus plus, similar things. After this base condition, we check this, we take this loop, okay, this loop which is this for loop, right here. One thing, j and cuts of I plus j cost. For this, what we can do, alright, so dp of I comma k minus 1, what? K can be where? I to j anywhere, right? Alright, so it's going to be like a dp of I comma k minus 1 for this, and plus dp of k comma j, like that, okay, and after that dp of I comma j is equal to dp of I comma j, wait, no, this will be mini, right? After this loop ends, then we find dp of I comma j is equal to mini. Alright, we have to initialize this mini also then, like this, control C here. We have to initialize this after here, All right. And what we should return after all of this? I is going from skirt size minus 2, right? So which is m here, and return dp of m comma I think 1, right? Alright. Well, now what we have to comment first this. Alright, m is cut short size, guys. Alright, and this m minus 1. I don't know what is I am doing, but yeah, let me dp whatever dp vector let me try this. Okay, let me check at j. Let's go for m plus. Okay, so this is I have to take it like this. Alright, let's check again. Runtime error. I don't know, guys. It's happening. Let's go for the Guruji first. Why it's happening? Alright, where is Guruji? What? Whatever. Okay, you are making the ultimate leap to bottom of W. So its bridge is high first. So you don't feel bad, right? So your structure is impressively close. You correctly recognize that I must backward while J must go forward. Alright, build the windows bottom to up. And however, the tabulation loop has fallen to 3 classic conversion trap, negative root trap, and the cloned cut trap, and lost trap. Wow. So it has name to everyone, right? Here is the mathematical real world. So negative loop. Look at your inner loop. J is equal to 1 like this, and J plus plus. You are measuring a piece of wood left and at the coordinate 4. 4 because J always start at 1. So you ask your assistant to measure the piece of wood from coordinate 4 to coordinate 1. Assistant physically cannot do this because the right end is to the left end. The right end is to the left of the left end. Okay, so a valid window must have I is less than equal to J. Alright, so by making j start at 1, you are calculating impossible states where I is greater than j. We fix this by mathematically forcing j to always start exactly at I, j is equal to I. Alright, so alright, and clone cut, okay. Look at your cost formula. dB of I comma k minus 1 k comma j. Alright. You make a cut at k. You hand the left piece I to k minus 1 to assistant A. And you supposed to hand the right piece k plus 1 to assistant B. Instead your code dp of k comma j physically clone the exact spot you just cut k and handed it to the assistant B. If you cut it physically at k, the remaining pieces are still I comma k minus 1 k minus 1. It must be k plus 1 comma j. Alright, so lost in our step also. Alright, so let me do these things first. Okay, so dp of k plus 1, right. One more thing, and j is equal to I here. Alright, these two bucks I have improved. Lost in our step is look at your return statement. Alright, the DP table I can hold the minimum cost to evaluate the window from index I to index j. The original recursive code you were trying to mimic was cuts of I comma or m-2. Therefore, the absolute final cost of I is m-2 also. Alright, so let's try this also, guys. Do it m-2. Okay. What? Let me check. One command minus 2, right? 1 minus 2. Let's check this out. Oh, it's working. Right, guys, so it's now reached 93%. So I think this is the one of the best solution you can find. Thank you so much, guys, for watching this, and we can make it as okay, done. All of this is done, and next we will do this burst balloons, evaluate balloon Boolean expression, palindrome, all of them. We will do all of these problems today only. Alright, so thank you so much for watching, and I'll be back, guys, right?